The standard shader is a versatile, physically based shader. It premiered in Unity 5 and represents the latest innovations in shading for games. The standard shader, as a physically based shader, is part of a physically based rendering workflow. What this means is that our materials here are going to react physically correctly to the light that hits them, depending not only on the angle of incidence from the light and the brightness, but how that shader is configured, using either specular and smoothness or metallic and smoothness properties to define how smooth a material looks and how reflective. Additionally, our materials are meant to take in an albedo, the raw color of that material without any lighting data, where the lighting data will be applied in the material based on physical shading models. I'll make a new material as an example and start to look at the rendering modes in our standard shader. I'll right-click on the project window and choose Create and Material. This new white material has no maps in it. It starts out as a standard shader in an opaque rendering mode, and its color is simply determined by that white in the albedo. In our standard shader then, we've got different rendering modes available: opaque, cutout, fade, and transparent. Most of the materials here in our Zombie Toys game are opaque materials. They need to look like solid materials with a color all over the surface. Occasionally we'll need different rendering modes, such as a cutout. We'll use the cutout to cut out or knock out parts of a material, dependent on an alpha channel in an image. This is useful, for example, for fencing or lattice work, places where we need to define perhaps fine detail with space around it. Our fade material is useful for things that turn off and on. In a fade material, we can animate on, for example, power-up icons. And finally, we have a transparent, where in our transparent, we'll define where a material has transparency as different from a cutout. As an example, this might be used for dirty window glass, where we can see through the glass partially, but it's got dirt and streaking on it. I'll look first at the opaque material. In an opaque material, there's no transparency. If we spin around this material, we can see it's completely solid. When we start to add textures in our material, then it determines the different properties. For example, I'll construct an arches material in here, dragging the arches diffuse into the albedo, and an arches normal into the normal. There's an arches occlusion for the occlusion, and we can see our material changing. What happened here is that the albedo determined the color of the material in light. As we orbit around here in the previewer, in the inspector, we can see that the normal map added the grain detail in the wooden blocks. We can see a bit of a specular highlight flashing across the surface, and the normal map makes it look like there's more detail on those. The occlusion map determines where indirect light is or is not applied. These now have the look of wooden blocks, ready for our scene, ready for the actual geometry. Just by adding those in, we've got a very realistic material. Now bear in mind that this is a realistic shading, but the artistic intent in the texturing may not be realistic. So it's possible to have, for example, very stylized or cartoony textures that react physically correctly. In addition to adding textures into our standard material, we also have a number of sliders. Our metallic slider, in this case, determines how close to a metal this looks. Right now it's at 0, meaning that this is absolutely not going to look like a metal. When we slide it all the way up to 1, we can see that the blocks really become almost coppery. This changes how that specular highlight appears and what the reflection contribution is on the surface. Sliding up and down smoothness then makes the material smoother or rougher looking. For example, with metalness and smoothness all the way up, this is a very, very shiny material. And we can see here in the inspector the reflection, again from our wraparound gradient sky, showing. Pulling smoothness back spreads the specular highlight, the bright spot, across the surface. So it's got still a metallic look, but is not as shiny and reflective. We can reduce metallic. We don't have to always have it at 1. Pulling it back about halfway produces a metallic paint on these blocks, for example. Not an actual metal, but a metallic paint. Simply by adjusting metallic and smoothness, even before we put a map in, can give us a very defined look for that material. Metallic and smoothness properties both use a single channel of an RGBA image to determine their intensity. By mousing over, we can see that metallic is in the red channel and smoothness is in the alpha, leaving the green available for another image, perhaps occlusion, where we can see G after the occlusion, meaning green. In our standard shader, we can choose to use some, none, or all of the different maps available. Any properties that need a map that are unused don't compile in the shader. This is how Unity economizes this standard shader, making it versatile and flexible, yet efficient to run. If we switch this material from an opaque to a cutout, we have some different maps available. In this case, what we can see is that we've got an albedo and an alpha cutoff. In the cutout material, the albedo has a possibility of an alpha channel. What this means is that the red, green, and blue colors in the albedo define the color of that material and lighting. The alpha then defines the transparency for the cutout, where that material exactly does or does not exist, as it's below an alpha cutoff. What I'm going to do is to change the diffuse map of this. What I'll do is to change the albedo slightly, and then use that alpha cutout to knock out around those blocks. I'll go into the Textures folder. And in here, I'm going to take the alpha from the grayscale for the arch's diffuse. I'll apply it and check the alpha channel. What we can see here is that it's black surrounding various grays in the blocks. Here in the new material I've made, it's, well, disappeared in the inspector, and here's why. That alpha channel goes from black through various grays, so sliding down that alpha cutoff makes those blocks appear. Depending on where that alpha cutoff sits, the material may be completely cut out. I'll pull that down, and now as we orbit around here in the inspector, we can see that the material is exactly gone where the alpha is darker than that cutoff value. As we can see, that specular highlight is traveling across the material and exactly stops where the material does not exist. And this is what differentiates the cutout from the transparent. In the transparent, we may see materials that are clear but still shiny across, such as glass. In the cutout material, where the material is cut out, it doesn't shine or reflect. In our transparent material, what we can see here as we orbit around in the inspector is that even though the albedo has the alpha, which is defining transparency, there are areas in here that are clear but that are shiny, and this is again that difference. It's still defining in that material where it is or is not a certain color, where it is or is not smooth, in this case all over fairly smooth, but the transparency is being defined in the alpha. And right here at the top of the sphere we can see a clear area shining. The fade, again, is useful for animated power-up icons, for example, or other things that need to turn on or emit in some way. However, the fade is a little bit outside the scope of this project. I'll switch back over to opaque, and what we can see again is that I've got areas that are exactly black but still shine. We have two variations of our standard shader, standard and standard with specular setup. This is really an artistic decision. What we're seeing is that the standard shader has the albedo, and all of the reflection and shine is determined by the metallic and smoothness properties. Smoothness for microsurface detail that spreads the light, and metallic for the appearance of metallic or metal surfaces. In our standard specular setup, then, we have a specular map and a smoothness. The specular map, then, determines the color and strength of the reflections, and the smoothness, again, is the spreading of light on microsurface detail in that material. This is really an artistic choice. Some artists feel that there's more control in a standard shader, while others favor the standard specular setup. The biggest concern when choosing the standard or standard specular setup shader and the different rendering modes within that shader is that those materials look correct and match the concept art and hero imagery and support the mood of the game and the gameplay.